Have you ever wondered how to isolate failures in a way that when something small breaks in one component, the whole system doesn't go down? Maybe there was something wrong with the release. Maybe one of your customers had used all resources of a database and it has impacted other customers. Maybe you have misconfigured one routing rule in a VPC and the whole system was unreachable for the weekend. What would you do to prevent such events from impacting the whole system? There's a special pattern in cloud development and system architecture to address that. That is the Bulkhead Pattern. By the end of this video, you'll know exactly what it is and how it may help you build resilient architectures. So the idea is to incorporate the bulkhead idea from shipbuilding into the cloud architecture industry. What if we architect our cloud setup in a way that we have these separate independent pieces, and when something breaks, one of them is unavailable, then the whole system is kept alive. Let's take a look at sample architecture here. We have API gateway for Lambda functions and DynamoDB table, all deployed in one AWS account. What can go wrong here? First of all, if this kind of setup is served to multiple customers, we have a problem of a noisy neighbor when one most active customer sends so many requests that we are hitting read throughput limits on DynamoDB table, and that affects other requests. We are unable to accept them. Another issue here is that Lambdas have a default concurrency of 1000 per account. This value can be increased, but still it is a fixed value. If one Lambda hits that 1000 concurrent executions, the other Lambdas will not be able to execute. Another disadvantage of this architecture might be that when we are releasing a new feature and something fails, it affects everyone who is using this API gateway right now. If we have downtime of this API gateway, it affects the whole system and all customers. And that is exactly why the bulkhead architecture is out there. It can help us mitigate that. Our bulkhead architecture may look like this. We have 3 pools and we can create other pools of resources. The end user sends request via load balancer. Load balancer is configured to route traffic to that user's resource pool, for example, to the pool number 1. This architecture helps us be more fault tolerant. For example, if one of the pools goes offline, for example this one, we still have 2 and we can route users to other API gateways and Lambda functions and DynamoDB tables as it is drawn on this diagram. This diagram very much looks like a tenant separation architecture, and tenant separation is one of the ways to implement bulkhead. Let's speak about the concrete patterns in more detail now. Bulkhead pattern can be implemented in 4 different ways. As service level isolation, queue-based isolation, resource pooling, and cell-based architecture. To implement service level architecture, we can, for example, isolate all Lambda concurrency levels and reserve the concurrency levels per customer, per tenant. Number 2 is queue-based isolation, that is about separate queues, for example, SQS queues per tenant or priority, so that the slowest user in a queue never blocks the other. And number 3, resource pooling. It is about dedicated connection pools or cache clusters per service. This way, one service can't exhaust the database connections or everything else. And finally, cell-based architecture. In the most extreme form of cell-based architecture, we can deploy the whole duplicate of our system in different AWS accounts, and this way they're fully isolated from one another. In case of bulkhead architecture, you're trading efficiency for isolation. In most production systems, especially anything customer-facing, that's the right trade. The alternative is letting one bad workload take down everything. That's all I wanted to tell you about the bulkhead pattern. In the next videos, I will dive deeper into the 4 implementations you see currently on the screen. Thank you for watching. See you next time.